The effect we take advantage of is called aeroelastic flutter. To any engineering students, which I don't know if there are too many, maybe Nicholas knows. There's a famous video that they show in schools in engineering or physics class, which is the Tacoma Narrows Bridge that's exposed to airflow, and it starts to wiggle and wobble itself apart. When I was a kid, I saw this video. I thought, boy, that's a lot of energy going into that bridge. And that stuck in my mind, and one day when I was trying to figure out a way to power LED light systems in Haiti for a separate project, thought, oh, maybe there's a way to use that effect to create a wind harvester that can be less expensive on the small scale than wind turbines. And that has morphed into a few different scales of technology for the Windbelt. Sorry, I don't remember the order of these slides. Next one. So maybe you can click on that and show people what the Windbelt looks. Actually, can you click on the picture? Previous picture.
Yep.
Okay, it doesn't work. Anyway, it looks like this. It's sort of, if you've ever seen a slow motion video of a bee flying, that's a lot how the system works. We've done a lot of development all around the world. For about a year, testing large-scale systems in Guatemala. We expanded our team by about 5 people. We've done work in Haiti, and we have our workshop out here now in Hong Kong, and one of the guys is in France, and another one of the guys is in California, who teaches at UC Davis. You can go to the next slide. We've developed some kits that kids use in schools around the world, so we have some distribution partners for these small Windbelt kits, and really it's a really simple electricity generator that a kid can put together in about half an hour and then put in front of a fan, and you see everything there. It's wide open, you know. Basically there's some magnets on the belt, it wiggles around at a high frequency and around some coils, and it produces electricity. People seem to like that. We get a lot of requests for that. Can go to the next slide and then the next one. We've also developed more on the industrial side, sort of getting to what Nicholas was talking about, smaller scale systems. We call this one the microbelt. Right now these fit in the palm of your hand, and they're intended to power the wireless sensors that are the key to getting those 50 billion machines online. You know, sensors are basically the fingers that go out from the internet and connect the real world to the world of the internet. HP thinks there's going to be 1 trillion sensors in 20 years out there in the world collecting data. 1 trillion sensors means 1 trillion disposable batteries out there in the world. Nobody wants that. One way to power those sensors is with small solar panels, of course. You can also power with vibration, thermal gradients. But as of yet, besides the Windbelt, there's been no technology that's been developed for micro turbines that can capture flow, be it wind flow or water flow, to power these sensors continuously. We believe that the Windbelt is going to play a large role in powering sensors in, you know, smart buildings, sensors on the sides of roads where you have a little bit of wind and you need a continuous little bit of power. Right now, like I said, these are about the size of a cell phone. We think they're going to go to about the size of a couple stamps in length. You can go to the next one. And we're also doing some more larger scale systems. This is sort of an artistic one that we're doing for a project. And these are 1 meter long. Eventually, we're hoping that we can increase the efficiency of these systems enough at higher wind speeds so that it's viable in arrays. You can think of it like a fence for pumping power back into the grid. Right now, it's not there yet. There's quite a lot of development left for that. We think the more immediate win for us is on the microbelt side, but we're still cooking along, doing that. And I did bring my little travel model, just so it's not all pictures. We don't actually sell or produce these. This is just strictly for the show. You can see this over some drinks. But basically, you have a frame and you have a membrane in tension. When air blows over the membrane, it vibrates at, this one goes at around 100 times a second. And then there's no gears, there's no sliding bearings, and it produces electricity. And no talk is complete without the parlor trick. let me make sure. Okay, so air flows like that, and then, okay, you got it. You can hear the noise there, but that's because this system is 2 years old, one, and two are 1 meter systems that are more developed, are designed to capture more natural flow rather than the wine-imbued breath that is going on this system. So the larger systems are, despite our company's name, Humdinger Xylem. That's it. Any questions?
Thank you.